Did you have a final when you did it?
Yeah, everybody has a final. You always have a test or a test for a final, unless it's a project. You always have one, but hang on, give me a second. But like some professors have a cumulative final, some don't.
Yeah, that.
You'd have to email her and somehow get her to email you back.
Yeah. This week is gonna be rough. Tomorrow I have to sign up for housing, then take my lab final, then Wednesday my other lab final, Thursday math and chem test.
My lab, I still don't know what's going on with my lab. I just better get an A for it.
Hmm.
But yeah, all right. You ready to go over linearization
Yeah.
or linear approximations?
Yep.
All right. So I did some research. Fun fact: it's not in the textbook that I use. So, but I do remember this now. I do remember this, but we use this to approximate lines near the tangent or at the point near the tangent because they're so similar.
Hmm.
Had I not been writing this out, I would have got a graph over to show you what I mean. But anyways, so the example I used, I tried color coding this. It didn't show up well on here. It kind of aggravated me. But example, it's f of x equals cube root of x at x equals 8. All right.
Mm-hmm.
And so we're going to use a linear approximation to approximate the values at cube root of 8.05 and cube root of 25, just to see. So you start out, you find the first derivative because you need to plug in everything to this formula. So you need f of a, which x is a, or x equals a, so this is a. So you found the first derivative. You plug in a to f of x, and when you plug in a to here, you get 2. And you plug in a to f prime of x, and when you do that, you get 1 over 12. Are you with me so far?
Yeah. Can you go scroll up just a tiny bit?
This?
Yeah.
Okay.
She never taught this, did she?
No, she did not, from my recollection.
Is there class tomorrow?
Do what?
Is there class tomorrow?
Yes. It's supposed to be.
Okay.
I think she gave y'all a quiz. That way she could like test out the thing before her test. Like test
Yeah.
out the Respond browser. That browser sucks, in case you can't tell.
Yeah.
You ready for me to go down?
Yep.
So you find all the values, and you f of a equals 2, f prime of a equals 1 over 12. Yeah, I tried over highlighting over stuff. It didn't work with the pink. And that's supposed to be pink. It came out purple on the printer somehow, and I don't know how.
Okay.
But wow, that's weird. Anyways, you plug it in. See, you have. I should have wrote the equation in. You have f of a, which is 2, f prime of a, which is 1 over 12, and then a, x minus a, which is that. So when you simplify, it comes out to be this beautiful equation right here. Oh, God. Makes sense?
Mm-hmm.
You plug everything in, and you get this equation. So when you plug in 8.05, you get this value. And you plug in the cube root of 8.05 on a calculator, you get this value. You see how close they are? Within 100,000th of a decimal? 1, 2, 3, 4, 5 decimal places. Yeah, 100,000th of a decimal. But when
Okay.
you get further away at 25, it's not accurate at all. Do you see what it's for now?
Is there something in the background?
Yeah, I'm hearing a large noise.
Yeah.
You just want me to keep talking, or?
Can you repeat though? The brewer kind of
This
out.
part.
Yeah.
So when you plug in 8.05 to this equation, you get a number that's within a 10,000th of a within 1/10,000th or within 1/100,000th of the actual answer. So you can approximate when you're really close to it using this formula right here. But when you're farther away, it's not all that accurate because the tangent line's so weird.
Ah.
See, this is the example curve. See how everything's really close right in here?
Yeah.
So when you're right in this area, you have the same x distance away. So it's going to be close to the actual line right in here.
So it's like the tan line at a point.
It's so close to the tan line, but yeah, it's pretty much the tan line. But when you get farther away, it's not as accurate. So when you want to get values within a small distance, you can do the linear approximations, and you're pretty much good to go. It just makes it
Okay.
simpler to find sometimes. So that's the whole purpose of it. Try this one. I know you're going to love this one. I'll be right back and give you some water real quick. Or hang on, before I do that, do you know the steps?
Yeah. Find the each value.
Yep, find the
Like.
derivative, find the values, and then plug it in.
Yep.
Okay, I'll be right back. All right, I'm back. How you doing?
Okay. Vanessa joined.
Hey, Vanessa.
Hey.
Do you know what linearization or linear approximations are?
I'm honestly quite confused.
This formula is what you need to know.
No.
You're confused about it, or?
Did we do this last time?
I don't think she taught it.
Yeah, she hasn't taught it, right? Yeah, I was confused. I was like, I haven't seen that.
Andy told me about it being on the quiz.
Right, I did see that.
So I decided to go over it.
Okay.
But yeah, all right, but I'll explain it really quick. Okay, so oh my god, if y'all see anything sketchy in my history, all right. So this right here, you see how at this point the tangent line, all the points kind of sort of mesh together. They're really close to each other.
Mm-hmm.
So what this is saying is you can approximate this point by using the tangent line when it's close.
Okay.
So when you So when you, hang on. Andy, that's making a sound again. Andy. Is Andy there?
I think he is.
I'm here.
It's making the sound again.
That bird's not me.
Oh, you hear it too?
Yeah, I hear it too. I thought it was you. Like,
Oh no, it's not me. I don't think, because I'm hearing it. Vanessa, you hear it?
What sound?
Yeah, I'm gonna mute myself. See if it goes away. Oh, if you don't, do you not hear it?
No, like what sound is it?
it's like rumbling sounds.
No.
I muted myself and it still did it, so I don't know. Yeah, I wonder if it's Teams messing up because everybody's using it. Anyways, Vanessa, you there?
Yes.
Okay, so if you have a function f of x equals q root of x and you want to evaluate it at x equals 8 or at x equals 8 and you want to approximate the values close to it, so at 8.05 and cube root of 25. This isn't really close, but it's going to make a point at the end. So you take the first derivative because you're trying to plug in everything to this formula.
Mm-hmm.
So you take the first derivative and then you plug in 8 to the original equation, which gives you 2. You plug in 8 to the derivative, which gives you 1 over 12. You following me so far? Because you need f of a and f prime of a, and a is 8.
Okay.
The point at which you're close to. So you come to the formula, you get f of a plus f prime of a times x minus a. And so solving that and stripping that out and simplifying, you get 1/12 x plus 4 over 3. Nice linear equation like a tangent line. So yeah, the sound is.
Is it from me? I don't know.
Yeah, I think it is. Do you got a vacuum in the background?
Oh, I have like a little like heater on.
Yeah, that may be it.
Okay, I'll just turn it off.
Yeah, I don't want you to be cold, but is it?
Is it better now?
Yeah.
Okay.
I'm guessing it was
I'm sorry.
twisting and yeah, that makes sense now. So if you plug in 8.05 to this equation, you get this. If you plug in 8.05, cube root of 8.05 into the calculator, you get this, and they're very similar because they're close to each other. But if you plug in 25 to this equation and the cube root of 25, they're not close because of this graph. It's less accurate. So the farther away you are, the less accurate it is. Make sense?
Yes. Is this like, I mean, she never taught us, like, is it going to be on the test?
I don't know. It's on the quiz. It's on the
Yeah.
homework. I'm assuming it's fair game, so you should prepare for doomsday.
Mm-hmm. Yeah, I did see in homework too.
Yeah, me and Andy got stuck on that Friday. And he told me it's on the quiz, and I smacked my head. And so, do you want to try this problem?
Sure.
Andy, did you do this problem already?
I got a funky answer. I got 30x minus 145. 130.
Close, but it's not right.
30x minus 135.
You're close, really close. All right. 33x minus 150. You messed up your algebra somewhere.
Let's see. For f of a, I got 15. Derivative, I got 30.
So f of 5, 15. 33.
33.
Yep. The derivative, I simplified it to this. E, or 3e to the 2x minus 10 plus 1 plus 2x, because you got to use the product rule this one, right?
For the f prime?
Yep. Product rule, because you got an x and an e to the, you got a function and a function.
Where do you get the 1 though? Like, I just did times 2.
Because you get this plus this, and I just pulled out 3e to the 2x minus 10. So you just took the derivative of this and did the 6x e to the 2x minus 10?
Wait, the derivative of 3x e 2x minus 10, isn't that just 6x e to 2x minus 10? No?
Nope. You got a function.
Oh,
A function.
so then it's the u prime v plus v prime u?
Yep.
Yeah, no, I didn't do that.
Thursday, I'm going to go over optimization. So
e to the 2x minus 10, how do you get the derivative of that?
okay, e to the 2x minus 10. If you take the derivative, it's e to the u times u prime, right? So it's e to the 2x minus 10 times the derivative of 2x minus 10, which is just 2.
2.
Yep.
So it's 3 e to the 2x minus 10 plus 6x e to 2x minus 10 for the derivative.
Yeah. And then when I simplified it, I just put it out here. Vanessa, how are you doing on this one?
What was after? Like, how do you take the v, u prime v, v prime u part?
So product rule. So say this is u and this is v. So
Right.
you want u times v prime plus v times u prime.
Right.
So you want 3x. I did it opposite.
I did that. How did you get like 6 for the second one? Like after?
Oh God. Same thing Andy had. When you take the derivative of e to the 2x minus 10, all right?
Oh,
E
okay.
to
I
the
think I
2x
get
minus
it.
10 times the derivative of this.
Right.
It's just 2, which goes to 6.
Okay.
And
I get it.
plus, I'm going to finish this out for the video.
Right.
The derivatives, man, they'll trick you out. That's why I chose this problem, really. This is 420, 2020, guys.
Super weed day.
Since the super weed day, the only one of the century. Oh no, this is the only one of the no. Wow, hang on.
No, it could technically count for next century, like or 2020 or 3020. Oh wait, yeah.
It's never gonna be 420, 2020 again.
No, triple 20. No.
This is a super ultra weed day. All right, y'all ready for me to go through this?
I didn't simplify it, but I got 15 plus 45 times x minus 5. I didn't distribute it yet because that's slow.
Right. Vanessa, you ready for me to go through it?
Yeah.
Okay, so you want to go through this function right here. That's what you want to plug everything into. So you found the I did f of 5, which is 15. You just plug in 5 to the original equation. This goes to 0, so this whole thing right here equals 1, or e to the 0 equals 1. So and you found the derivative, which you found up here. E to the 0 times 1 plus 2 times 5, which is equal to 3 times 11, which is 33. So you plug in f of a, 15, plus f prime of a, 33, times x minus a, which is a is 5. So you get 15 plus 33x minus 165, and it simplifies to this. Did I lose anybody?
On the derivative, let's see.
I'll put this as my u and this is my v. So the derivative of v is just 3, and e to this plus 3x times e to the 2x minus 10 times 2. And to simplify it, because I knew I'd be plugging stuff in, I pulled the e out here because it always turned to 1.
Oh, so I did 6x. Would that be wrong?
So you did 3 plus 6x.
And I did a 3e 2x minus 10 plus 6x e to 2x minus 10.
Oh yeah, that's the same thing. I just pulled out a common factor.
I got 45. For some reason.
1 plus 2 times, or so this, we're going to say 3 plus 6 times 5. So 3 plus 6 times 5 is still 33. Vanessa, are you good on this?
Oh shoot! Yeah, I messed up.
Yes.
Yeah, I see what I did wrong. Yeah, 30 plus 3 equals 33. I was reading it wrong. You're right.
So, Andy, does this look similar to you? Or was that that's what you sent me last night? Is that the question?
Yeah, that's the question from the quiz.
Yeah,
Vanessa,
I've seen that too.
that is. Was this one of the answers? Because I may have done this completely wrong.
I remember one of the answers was 8x plus 1,
Yeah.
x plus 8, 1/2 or something like that. I don't
There was
remember.
something like square root of something.
I hate
It
the
was a
first
lot
part
of
of
stuff, so I just went with 8x plus 1 because that was similar to what the homework did.
I did that too.
Yeah, I might have got it right. I have no idea. Like, I forgot how the first part of the fundamental theorem of calculus works. Is the heater back on?
No, it's not. But I can hear it now.
Yeah, I muted myself while I was rumbling too, so I think it could be just servers.
Yeah, it's probably Microsoft. Of course.
Yeah, now I can hear it.
But I'd let u equal x plus 1, so du dx would equal 1. So d dx, this is the first part. I don't know if this is right. But the linearization or linear approximation isn't hard. It's this guy right here. It makes it so hard.
Yeah. Well,
So I let u equals x plus 1, so d dx of this to u plus tangent pi over 4t. So I saw this on a lot of using the chain rule whenever we want u tangent pi over t. That's what it's about. It's supposed to be u minus 1.
I'm gonna leave it join again, see if something. Okay.
It says it's nicer. Well, I messed up. See, u equals x plus 1, and since this is just t, or no, you can plug it into u. And then you do x plus 1, yeah. Okay, because you had u. And then tangent of pi over 4 is always 1. So when you plug in 1, you get 1. So I did do this right. And so you get 8 plus this equation right here, because when you did the definite interval, you get that. And I distributed, and x, do what?
How did you get the 13? Oh, is that okay? I saw like I was that. That's minus 1.
Yeah.
Okay.
Yeah, sorry.
No, you're fine.
Or so -1 from the derivative.
Yep. No, -1, yeah, from the derivative ddu. Because when you take tangent of pi over 4, it's 1.
Tangent of pi over 4 is 1.
Yeah.
Oh, so when you do the derivative of tangent of pi t over 4, it's just tan of pi over 4?
No. Or because this is the derivative of the integral,
Okay.
which I may have messed up again. Yeah, that's where I messed up. I didn't take the derivative of all that. Whoops. Oh, well, this is a bust. Yeah, I hope y'all understand this part, like the linear approximation. It's that part. I need to work on that part. So yeah, we're going to call it on that. I may work on that Friday if y'all don't want to do homework. You just get a bunch of those problems. All right. You want to do definite integrals, the second part, which is the only useful part? Anyone there?
Yeah.
Yes.
Okay. Start out with this one. I'm going to post this, and I think I did like 15 or 16 of these example problems, so you'll have examples. So y'all should be good on this part. This is like the most important part besides derivatives of this whole class. So I was doing a strengths homework, and I literally stopped in the middle of it to write a program because I got tired of putting stuff in my calculator. It's the first time I've done that in about a year.
I got 12.
Vanessa, how'd you do? You're still cranking it out.
I'm still working.
All right, I'll give you another minute. Yeah, there's no way we're gonna be able to do all the ones I did because of that linear approximation thing. That fundamental theorem of calculus, I really hated it. And the fact that she makes a big deal out of it, I don't know what she's gonna do in the class. But all right. So y'all got to the antiderivative part at least, right?
Mhm.
All right. So that's the antiderivative, and you
Oh.
evaluate it from 1 to 3. This is the second part of the fundamental theorem. So you get f of a, or no, b minus f of a. Y'all remember this much at least?
Yeah.
So,
I just plugged it in by accident. So my answer's completely off.
yeah. So when you plug in 3 up here, you get this minus this right here. When you plug in 1 over here, so you get this right here, and it simplifies down to 8. How'd you do, Vanessa?
Yes.
All right, you got it.
Uh-huh.
All right. This one shouldn't take long.
Do you mind scrolling up a little bit?
Oh,
Oh, okay. Yeah, you could do that.
okay. Yeah, that's just me plugging stuff in. I really wish that tablet would have worked. 1.01 to the 100th power is 2.7. That's crazy.
Okay.
You don't trust your answer, Andy?
I assume I do.
All right, so this is the antiderivative. If you don't get this, I don't know what to tell you. So for f of b minus f of a, you plug in 1 to the 101st power divided by 101 minus negative 1 to the 100th power minus, or to the 101. An odd number to an odd power will always be odd. So you end up with 1 minus negative 1 all over 101. So it comes out to be 2 over 101. How'd y'all do?
Yeah, got it.
Yeah, I got it.
Okay. Ooh. This one was not fun. It's just annoying. Actually, no. It simplifies a lot easier than you think, but still.
Is that a 3? The second one?
Yeah, it's a 3, sorry.
Okay. You're fine.
The pencil didn't go that loud. How y'all doing so far?
Almost there. Just give me.
Yeah.
Ah, dang it.
Y'all excited to have 2 more weeks left of school, including finals?
Oh, yeah. Well, yes, but I also have to find a job.
Oh, you ain't gonna find a job right now.
An essential worker job. By summer, anyway.
It's gonna be hard for you to find that. I know.
I always could go back to McDonald's. They said they'll let me work from the first day I want, but I really don't want to go back there. Because they never technically fired me, or I never really quit. My name
You're
is
still
still
on
on
the
the
payroll.
No, but my name is still in the system. I can work whenever I want, but I really don't want to work there.
That's nice.
Yeah.
I'm
They
taking
gave my
some
brother a
courses.
bonus, and I never got one when I went to college. And they're like, "Oh, my brother's going to college now. Let's give him a bit more money." And even I worked with them for a whole year when I was still in college, also.
Oh. They pick favorites, don't they?
And they liked me, but I guess I didn't have the money to waste at the time. I don't know. Well, McDonald's always has money to waste. I didn't feel like it.
Okay, so you get -0 over here because when you have a 0 on the left, on the bottom it's almost always going to be 0 on the right because you go up a degree. Anyways, you get all this, and then it's just algebra, cranking out the algebra. So what'd y'all get for the answer? I got
thought
2.
that's a really weird answer.
I got 2. Is it in your algebra? Did you at least get here?
Yeah,
Yeah,
I
I got
did.
the antiderivative, and I was gonna plug it in. And I was working on that, but
So this is 4, 8, and 16. So you get 16 over 5 minus 8 over 4, which is 2, plus 4 over 5. So 16 plus 4 equals 20 over 5. And then 4 minus 2 is 2. Because this equals 4. All right. Let's try to get a couple more in.
when it's 0 at the bottom, does that mean we could technically not bother? I mean, sorry. Yes, we. Never mind. I said it wrong now.
You can bother it, but if there's a 0 on the bottom, the right side will most likely always be 0. As long as it's not like e to the x. Always be careful of e to the x.
Yeah. These antiderivatives have been, or integrals have been weird. I need to remember how to do the box method that she taught first, because I don't remember that at all.
She's taught a box method.
Or the whole left and right side, or up and down of a graph.
Yeah, I don't know. I'm not gonna lie. As soon as once La Hopital rule started, I sat through that class and I stopped sitting through the classes.
Is that a 7? V to the 7?
Yeah.
X minus.
Let me skip down a few after this so we can get through some good ones. These don't take too long.
Shoot.
For Calculus 2, I had a homework assignment and he assigned 164 definite integrals for one homework assignment.
Wow.
Yeah, and they weren't easy integrals like this. No.
Plus 2 times 1.
Vanessa, are any topics really messing with you?
Honestly, the last class we had, I'm not really sure if I understood the dimensions thing.
Thursday, I have 4 optimization problems.
When isn't it? Has she said when the test is? Is it this week or next week?
The test?
Yeah.
The final?
We're
Not the
gonna have a
final,
test
but
too.
the fourth test.
There is one on the syllabus. She hadn't updated y'all. She doesn't update y'all near enough.
Like, how many tests are we gonna do? And like, she has a quiz too.
Yeah, you're gonna do the final test probably Thursday.
So there's no like finals. There's just like a test. Like,
Oh, there's a final as well. The final's cumulative. She may cut out test 4 and just put it all in the final because of time. Like y'all missed a day and whatever.
Yeah, that's one of my teachers did. There's two tests. There's two the final test.
Okay.
They're both nice and kind of mean, but
Can you mute your mic real quick? Yeah, okay. I think there's some interference coming through your microphone. All right. I'm gonna go through this real quick. So when you take the antiderivative of this, you get v minus 2v to the 4th plus 2v to the 8th from 0 to 1. With these, you can leave out the plus c because when you do f of b minus f of a, the c's subtract each other.
oh shoot.
So you
I
don't need to
did
worry about them.
instead of okay, I messed up. I did 2v to the -1 to -4 by accident. I forgot negative. I
Oh,
messed
that's like
up.
a -3, isn't it?
The negative minus a negative is more, higher. I messed up there.
That's a +3.
Yeah. Okay.
Well, I'm gonna go through this real quick, and then since you have a 0 on the right, you don't need to That's going to turn out to be 0. So you plug in 1 to all these and get 1. I bet that little spot up there was literally a piece of eraser off my desk.
How did you get the 8 in like the second to last step?
This one right here?
No, after that.
Oh, wait. You're right, that should be 2.
Right, okay.
I got the answer to be 1.
Yeah.
Mm-hmm. 2.
Yeah. I saw that 8 up there. And I thought, yeah, okay. My bad. This one.
This is technically the area under a curve from point to point.
Yep. That is technically what this is. Y'all should probably prepare for those linear approximation problems like she did on the quiz, because it feels like she's just getting those from the homework, like straight out of the textbook. And I don't have y'all's textbook, so I can't see the exact problems that I asked you.
Like for the quiz?
Yeah, or anything in general like that.
Okay.
The whole y, or yeah, find the linearization of 8 plus the antiderivative of point. Yeah.
I hate the first part of the fundamental theorem of calculus. It's pointless.
I got 20.
All right, valid guess. So you can rewrite this as, oh wait, no, never mind. You can rewrite this as x to the 1/2. I did do this right. I took the antiderivative and then simplified it. So that's the antiderivative. You get 2/3 x to 3/2. And you evaluate it from 1 to 9. I don't know how you got 20. So you get 2/3 times 9 to the 3/2 minus 2/3 times 1 to the 3/2. So 9, take the square root of 9, which is 3, and 3 cubed is 27. So you get 2/3 times 27 minus 2/3. So divide this by 3, so you get 2 times 9. So you get 18 minus 1, which is 17. Wait. Let's say 2 minus 2/3. God, I was making mistakes. Yeah, sorry about this, guys.
Oh, shoot. Yeah, okay. Yeah, I messed up my antiderivative.
So this should actually be I'm so good till the very end. Sorry about that. But that's the final answer. It's 52/3. What? How did I turn? I don't know. Forget textbooks don't give you easy problems. All right, try this one. Maybe I didn't mess this one up. This one should be a simple number.
Got 3.
Yep. Vanessa, what about you?
I'm still doing.
Did you get 3x to the 1/3 as your antiderivative?
Uh-huh.
Okay. So you can pull out the 3 from all this if you want to. You don't have to do 3 times this and 3 times this. But you do 8 to the 1. The cube root of 8 is 2, and the cube root of 1 is 1. So you get up with 3 times 2 minus 1 and end up with 3. All right. You want to try this trig one? I know y'all love trig.
I hope the test has a equation sheet for trig stuff.
You know better. Life isn't that nice. All right, let me know when y'all get this one written down. I'm going to search for a quick problem, another problem, or one that I want to do. Y'all got it written down?
1 second, sorry.
All right, you're good.
Yeah.
All right. You're going to the next one. Do what?
Like the different rules that she explained, like she wants us to know it. Like we have to know that stuff.
The rules. What do you mean, like the theorems?
Yes.
So like mean value theorem, the fundamental theorems.
Like so like for like the constant multiple and like
summations?
Yeah.
I did those last week. They're up on YouTube. They should be at least. But I got area under the curve. I got the approximation. But yeah, that slide with all the rules, you do need to know that in case she does Riemann sums.
Okay.
Last Monday I did Riemann sums. They take up a whole page. Andy didn't like them. He stuck to it.
All right.
Did y'all get negative cosine as your antiderivative?
Yeah.
Okay. So you plug in pi and pi over 6. You get -1 times -1 minus square root of 3 over 2. So you end up with this, and I just simplified to that. What's going to get you here is your algebra, as long as you can take antiderivatives. All right, try this one.
Oh, when I did the mock quiz, every time I would look down to write on my scratch paper, it would say, "Can't see your face. Please look up."
I hate that browser. I don't like the evasion of privacy. But I'm taking online classes, so I'm probably going to have to deal with it. And Vanessa, were you talking about like the k squared and like knowing what that is and the k cubed?
Like right now?
No, like did you know like do you like when you can turn k into like 2n plus 1 times n plus 1 or something like that?
Yeah, I know that.
Yeah, those. I don't know if you have to know those. You should probably write them down on a little sticky note.
Yeah, that's what I was thinking.
And stick it on your monitor screen.
Uh,
As long as the camera can't see it.
right.
But don't do that as cheating, wink wink.
The stuff that you did the last class.
Optimization.
Like the dimensions.
Yeah, the box.
Yeah.
Thursday. Come back Thursday. If you can't make it Thursday, it'll be up on YouTube. And I got a PDF. And I got lazy. Those problems take forever. I got the problems out of the textbook, and I was like, I had an epiphany. I was like, wait a minute. Chegg has all the solutions to all these problems. So I just copied and pasted all the stuff, like took snapshots of everything, put it on a Word, and it's all in a PDF document. But they all go step by step, showing you what to do. I'm just going to walk everybody through it Thursday.
Okay.
So that should help a little bit, because I hate optimization. I hate optimization, the first part of the fundamental theorem of calculus, and the related rates. How'd you do on this one, Andy?
So I got E5 plus E to negative 5, so E5 plus E5. I don't know how to write that as fraction. Or 10.
This isn't e to the x. This is just e, so it's a constant.
Mm.
So technically, you could pull this out of the integral, and it'd be the integral from negative 5 to 5 to dx, so 1. So it'd just be x.
Okay.
So e times x from negative 5 to 5. Plug in 5, so you get 5e minus negative 5e, which is positive 5e, so 5e plus 5e equals 10e.
Yeah, I left it as like, instead of 5e, I put E5.
It's the same thing, but
yeah,
as long as it's not up in the exponent part.
So I could just combine the regular numbers.
Yeah. Let's go down. I have u sub on this thing. This is just distributing the square root of t and doing the fractions. Why did I have that little line there? This is dividing. You divide by exponents. When you divide, you subtract on the exponents. All right. This is going to be the last one because I'm going to explain something after it.
Okay.
They're all going to be up on Teams, though. This is cosecant cotangent of t, and this is pi over 6 and pi over 2. I don't know if she's taught y'all u substitution. I'm going to let y'all know because it makes life easier because she did it on the first part of the fundamental theorem, so I'm going to assume that we can do it on the integrals.
Would the antiderivative of this just be cosecant squared of t, negative?
Nope.
Or
just negative cosecant.
Or positive negative cosecant?
Yep, because the derivative of cosecant is negative cosecant cotangent.
Oh, yeah. Okay. I thought it was squared. I don't know what pi. I forgot what cosecant, cotangent, and stuff.
Cosecant is 1 over sine, and cotangent is cosine over sine. That's why I'm doing this problem. Okay. Trig review, everyone's favorite. So apparently they're coming out with a Microsoft Teams for consumer app, so you can connect to all your friends and family.
Was that not possible?
No, that's only for business. You can only connect to people on here that are within the Kennesaw ecosystem. I had the at kennesaw.edu.
Oh, really?
Yeah. So you just gotta use plain Jane Skype. And what Microsoft Teams used to be was the Skype for Business app, but they changed it to Teams and people liked it more. So I think Skype may be gone the way of the dodo.
What about Zoom?
I don't know. I'm glad we didn't use Zoom. SL was trying to get everybody to use Zoom. And then I noticed, like, hey, they only let you do 40-minute sessions, and then you have to pay to be able to record. No. Why not we either use Skype or Microsoft Teams? And then you can record on here. If you press Windows, if you have Windows laptop and you press Windows Game bar, you can record your screen. It just uses a lot of data because it records everything raw. But yeah, all right, I'm gonna go ahead and go through this one. So you get the antiderivative, negative cosecant t from power of 6 to power of 2. So I pulled out the negative 1 and I got cosecant of power of 2 minus cosecant of power of 6. And breaking that up into sine and cosine, like you always should do with derivatives. Get 1 over sine over power of 2 minus 1 over sine over pi 6. This is where I messed up. I had to erase. I got mad at this. Anyways, negative 1 times 1 sine of power of 2 is 1 minus 1 over 1/2 because sine of power over 6 is 1/2. So you get negative 1 times 1 minus 2, you get 1. Now, why I wanted to go over this, so instead, we're going to let u equal cosecant of t. All right. And so we're going to take the derivative of that and say du equals negative cosecant of t cotangent t dt. And then we're going to change the limit. So when t equals pi over 6, u will equal 2. And when t equals pi over 2, u will equal 1. It's the same thing as when you plugged up in over here. And so we're going to say from 2, because when u equaled pi over 6, it was 2, to 1 when u equaled t equaled pi over 2, it was 1. You plug those in right here. You get negative du because it was only cosecant cotangent, so you bring the negative out. I understand this is really quick and y'all shouldn't be learning like this, but oh well. And then when you take the integral, you got to do a negative because this is from 2 to 1. So you got to change it to negative 1 to 2 negative du. And you could actually pull that negative sign out and cancel it out. But so when you do all this, you evaluate your integral, you end up with 2 minus 1, and it gives you the same exact answer. Now, this is called U substitution, and it's probably one of the most important methods in integration. Y'all want me to explain that again? Do y'all at least follow the first part, like the way y'all know? Give me something. Because you know she uses U substitution a lot, so this is the one of the only places where I really see it being useful. This is what she uses use substitution a lot because of integration, because it's used a lot. But all right, did y'all at least follow this part up here when you get to this and you plug everything in?
Yeah.
So right here, this is all just in this setup. We're gonna let you, because right here, you want to replace everything in terms of u. Okay. And you don't technically have to do the changing the limits. It just makes life easier sometimes. You could just take the antiderivative of this and then plug back in negative cosecant of t, and it would make life easier, or somewhat easier, and you don't have to do this part where you change the limits. But you let u equal something, and you let du equal something. And really, this should be negative du equals positive. All right, and then bring down the rest of this. And so you plug in negative du in place of this right here. You plug in negative du. And then so for the limit, you want to change the limits because a lot of times it makes your life easier. So when you take this formula right here, so when you plug in pi over 6, it equals 2. When you plug in pi over 6 right here, so cosecant of pi over 6 is 2. When you plug in pi over 2, u will equal 1. So that's where you get this right here. Y'all understand that?
Mm-hmm.
I need to do more. There's another couple examples, but we don't have time for that today. I'm sure y'all just probably got annoyed because I thought it was something completely new on y'all. And so if you plug everything back in, and then you solve that. See how this integral is way easier than this one up here? That's why we do u sub. And sometimes you need to do u sub because when you get something like this, you have 1 plus r to the 56th power. So you can let u equal 1 plus r. You can let u equal 1 plus r, and then you'll only have u to the 56th power, which you can integrate that. This one you'd have to expand to integrate, and this, yeah. So, all right. Well, that's it for today, guys. Sorry if I confused y'all again.
No.
Y'all have any more questions that I can try to help you with about the session? What I'm covering Friday. Y'all want me? Okay. Andy, do you want me to do fundamental theorem problems Friday, or do you want to do the homework thing Friday?
Which one's fundamental theorem?
The one like the quiz or like on the homework, the first part.
Okay, which one?
The one where you have like from 0 to x or whatever, and you have plus t. You have a
0 to the
t.
x, and you have like d of t.
Yeah.
Yeah, we could do that because that's the hard part about the linearization anyway.
Yeah. I should know. I think Microsoft servers with all this buzzing is all right, guys. I will catch y'all later.
Okay. I'm not sure if I'll be able to come on Thursday because I have
It's
an
going to be on
exam.
YouTube.
Yeah, but I'll try to.
It's on YouTube if you have any questions, or you can just look at the notes.
Okay.
All right. I'll see y'all later.
All right. Thank you.